close with these guys providing an awesome update to the projects that they're working on. We're actually going to hold Q&A because, believe it or not, it's actually somewhat sunny outside, and I want to get us outside. So we're actually going to, as a bonus, they're going to hold questions, Q&A, at where we're going to the rooftop afterwards. So we're going to do about 20 minutes here of a quick update from the 256 Foundation. We didn't mine a block yesterday. Who was here for the telehash yesterday? Quick show of hands. Let's go. We had the telehash number 2, which was awesome. And we did not mine a block. But we announced, or we talked about 4 incredible projects. So we got 20 more minutes. Still in the back, grab a drink. Brains has a bunch of beers that they were kindly enough to donate. Marshall Long and his team brought them here. So feel free to grab a beer, sit back, and hear from these fine gentlemen. So we'll do 1, 2, 3, 4. Can you guys join me in giving me a huge round of applause to Scott, Eco, Jungli, and Ryan Kuster?
Good job, man. Good job. Well done. Well done.
No, keep that applause going for Rod. Stand back up here. Come on. Thank you. Thank you for putting this all on. So everybody, reach your hand out. Pat yourself on the back. You are the strong. You are the survivors. You made it to the last panel of the day.
Let's go.
We're going to keep this short and sweet, and then I'll go get a drink. So you're looking at 3 grant recipients from the 256 Foundation. The mission of the foundation is to dismantle the proprietary mining empire. You hear a lot about mining centralization being an issue, and you hear a lot about all sorts of problems related to Bitcoin mining. Interestingly, the protocol itself is open source. The apps built on it are open source. Open source seems to prevail everywhere in the Bitcoin ecosystem. But for some reason, when it comes to mining, Bitcoiners have, by and large, just accepted closed and proprietary solutions. And Rod and I thought that was total bullshit and decided to start a 501c3 public charity to raise money to try and be the change that we want to see in the world. And we came up with the 256 Foundation. And Scott, you were the first grant recipient. And then for anyone who was at our first telehash, we solo mined a block with the donated hash rate, and then we were able to fund the other projects. So Schnitzel is missing. He had to fly back home, but he's running the other projects. So we won't have the Libre board represented, but I think we can fill in enough. So why don't we just go down the line and introduce yourself, and at a high level, just let us know what you're working on for the 256 Foundation. And Scott, why don't you go ahead and start?
Okay, yeah, my name's Scott. I got pretty into this starting the BitAxe project, pretty into the idea of mining that people who want to tinker with this stuff could get into and mess around with. And it turns out that when you learn about how it works on a deeper level and you have the ability, the sort of way to learn how this works kind of unencumbered from restrictive proprietary licenses and like obfuscated code and binaries and things like that, it's really, really interesting. So I got way into it through the BitAxe project, met Rod and Eco, and when I heard they're going to start the 256 Foundation, I was like, this is the best thing ever. I absolutely want to be a part of this. And so tried to weasel my way into that project as much as I could. We talking with Eco quite a bit, we came up with the idea of doing a hashboard. So this would be a smaller hashboard than you might find in an S19, like in an Antminer. Those are usually like 1,000 watts, but bigger than a BitAxe, and definitely a hashboard. So it'd be a part of a complete system, like something that you could put multiple in there. Whereas a BitAxe is a standalone system. It's you plug it in and it doesn't really scale up or anything like that. So the idea was the Ember One. We're going to make a small hashboard, landed on 100 watts, and do it with the Bitmain chips. We picked the chips out of the S19J Pro, mostly because they are old enough that they're very cheap, but new enough that they're part of the modern empire, the modern era, I would say, of Bitcoin mining chips. For those who think about how this stuff works, they roll version internally on the chips, so it means you don't have to send data to them as fast. They have a lot more work they can generate internally, so it's a lot easier to deal with JPro chips and newer from Bitmain. So we decided to go with that, 100 watts. Small little hash board, it's like 125 millimeters square. It is precisely sized to slide into an S9 enclosure if you want to do that. And it has a USB connector for the data. That's kind of cool because now you can plug it into a computer. It has USB. You can plug it into a computer. It mounts as a serial port. You can run Mujina firmware. You can write something crazy in Python. It's very hackable. It's very, very hackable. It's super practical to just screw around with it. There isn't like Antminers have a proprietary data connector. It's like you're not going to find this for anything else. So you kind of have to have their system to use that. But USB is a universal serial bus, so you can just plug it in anywhere. Pretty cool like that. Wide input voltage, 12 to 24 volts. So you can power it from a variety of things like those power supplies for those S9s back there, maybe a solar panel, maybe a bunch of car batteries, kind of up to you.
And working with those Bitmain chips, that's a pretty simple process, or it's well documented? Is it?
Maybe they have documents. I don't know. I've never seen them. No, I've spent quite a lot of time reverse engineering how they work. Because Bitmain doesn't provide any documentation towards how they work. There's some repair guides that are meant for the repair industry, but they're terrible. So for the BitX project, spent a lot of time figuring out how they work. A lot of people joined in and helped out. That's kind of one of the beauties of open source here is there are a lot of people who are like, I also am very curious about this, and I'm an extremely talented engineer, and I want to work on this like day in and day out until we figure it out. So we formed a team of just interested open source developers who were like, let's get this figured out. And we did, and have a pretty good understanding of how it works. I hadn't done the JPro chips before, but luckily they work very similar to the S19 XP chips, which we've used in a BitX before. So once you figure out how they work, it's all right.
And are there more friendly chip manufacturers that might help us make more generations of the Ember One?
Yeah, absolutely. This is a relatively new thing that there are other manufacturers that want to play ball. A couple years ago, Intel got into the game. They were going to make chips. They spun up a full process to make ASICs. They built machines, sold them to lots of large miners. They made millions of chips, and then they canceled the project. I think it was unrelated to how the business was going. It was just some sort of bean counters being like, don't do that one anymore, and canceled a bunch of other projects too. But there's millions of these chips out there. They are still useful. They're probably not useful for a lot of miners. They're sort of like 30, 35 joules per terahash, that era chip. But that's fine for home miners. That's fine for heat reuse. It's especially cool because there's a data sheet out there. We have some reference designs, some idea of how these work. And we were very graciously gifted 256,000 of them for free from Block, who had been screwing around with them. And we're going to make an Ember One with those Intel chips. That's going to be the next version. And then Aradyne has shown some interest in playing ball. Let's give these plebs some chips to screw around with. And then Block is also making an ASIC, and they have pledged to provide chips to projects like this. So that's kind of the roadmap there.
So the 256 Foundation's got the idea for the hash board, and we've got a roadmap for multiple kinds of ASIC chips. But does that dismantle the proprietary mining empire? There's more to the puzzle, right? So what else are we doing to achieve that mission? Right. Should we hand it off to should we do the firmware next? I think the firmware.
Yeah.
Let's hear from Ryan.
Sure. Although I'll do a brief stand-in for
For Schnitzel. Okay.
Because there's another piece of hardware. Scott's talking about the hash boards. We're also building a control board, which can be connected to multiple hash boards. And on that control board is everything you need to run the hash boards, but also accessories to run system-wide parts. Like if your system had a fan, if your system had a pump, if your system had temperature sensors, anything system-wide, because a system may have multiple hash boards, but only one control board. And the control board is an embedded Linux system. And on that Linux system is our Mujina firmware. And I'm the dev lead for the Mujina firmware. The long-term goal is Mujina will be a complete Linux operating system distribution for miners. So our first target for that system is 256's own hardware, the hash boards and the control board. But we intend for this to be very portable to both other types of control boards, other mining systems, and various hash boards. It will support all of the Ember boards, but even we have our eyes set on this being a very universal mining firmware solution for anything we can port it to. And that's the goal, to make the open source Linux project of mining firmware, so that people can use it on their systems in any way they like. They can modify it in any way they like. They can use it to explore every facet of the hardware they're interested in tuning, fine tuning operations or integration into larger systems in a way that, I've heard all day about things that can't be done with industrial mining systems because you can't control certain parts of it. We're trying to build a completely open system and unlock that openness on even other systems through the firmware that we hope to run everywhere possible.
And I think you're a really good candidate for this project. Can you talk about your background briefly, just to...
Oh, sure. Well, I'm a double E by training, but very quickly went over to the dark side of software and have spent my whole career writing embedded software, and particularly embedded Linux stuff. So since we were putting Linux on small 4 megabyte raw flash devices, and now, what we have in embedded devices is basically what we used to have in a server. So it's hardly embedded anymore. But software that interacts directly with hardware has been my bread and butter. So, and also that entire space is the kind of open source, open space that we want to turn mining into. So, when you're doing an embedded Linux project outside of the mining space, you're using completely open source hundreds of open source components, millions and millions of lines of open source code that people contribute to from all over the world. But you can go, first of all, you use that to gain the leverage of reusing all this stuff that people have already built. So you're not starting from scratch. And then it's also completely open to you. So when you find, something on your hardware that doesn't work in your unique case, or some unique thing you want to do, or new piece of hardware you want to support in your system, you have the source code to hack that in yourself without permission, without help, without paying anyone, without a vendor lock-in of any kind. So that same ethos totally belongs in mining hardware. So that's why we're doing this. And also, it's not going to just be me. I'm just the spearhead of what we hope to turn into a very large community project, because just the way that the Linux kernel and all of the components that go into a Linux system, they are all open source, community contributed to projects. Our firmware will be the same. So I'm just starting the ball rolling.
Yeah, and so if you're starting to see the full picture here, so now we've got our hash boards, we've got a control board, and some of the things Ryan was touching on when talking about the control board is, like, imagine you've got your miners now able to activate relays in your home's heating system. And so that's where Schnitzel really shines. So that's why we're building the control board in such a way that it can integrate with all these other systems as well. And the firmware is central to that, and it's going to be open, and anyone using that firmware can go in and change any parameters they want. They don't have to ask for permission. They can go ahead and start tweaking things to make Bitcoin mining fit very well into their unique business models or their home application. So I think you can kind of start to see our vision with those three components, but it seems like we still haven't dismantled the proprietary mining empire. What's the missing piece here? We want to do the whole stack. So what's missing here?
But before we go to what is the next piece, like, I mean, just this itself, isn't this so exciting? Like hashboard, control board, the firmware, the whole Linux distribution. Is this not so exciting? I mean, seriously. So kudos to you guys. Like, seriously, this is so exciting. And I'm just super honored to get a chance to kind of provide that last missing piece, which is an open source mining pool, right? So you got everything going here. You can do your innovation on the clients, right? Which is the control board, the hash board, the Linux stuff that I don't get, right? But then you need to kind of have an open source stack where you can point this hash rate to, and you can innovate on, toying with different kinds of payout mechanisms, trying to figure out different, accounting schemes, whatever you want to do. And surprise, surprise, there is no existing stack out there. So there's CK Pool, which is an amazing tool, but it does, it's a kind of it's a niche product which fits into a niche solution, and it doesn't let you kind of easily deploy things. So what we want to do is kind of take CK Pool, which is again an open source product, and kind of tweak it to satisfy more and more demands of developers, of pool operators, of miners who just want to club it together and run their own pool. So this is the final piece missing there, which is that open source mining pool, which we call Hydra Pool here, which is what we are building towards. And hopefully we'll get some contributors there too.
And you wouldn't happen to have any sort of like experience with like distributed systems or anything like that that you can touch on, would you?
From my past crimes, I tried to be an academic. I did a PhD in distributed systems and then just turned even worse. I joined the startup world, and that's my little bit of background. And now I'm finally found home in Bitcoin, I hope. So there we go.
So we've got 3 minutes left. And I think this is a good time to let Ryan ask Scott a question.
I'm asking because you can speak to this more eloquently. Can you explain how we're building this hardware and software, but we intend it to be a reference design, in addition to something people can play with and a hobbyist tool like BitAxe? These are also intended to be reference designs.
Yes, exactly. So they're going to work, like all the tools, the Ember One, the Mujina firmware on LibreBoard with Hydra Pool. They're all going to work as a cohesive system. You could plug and play and run it, but that's not the goal here, right? We're not trying to create a system that we're just going to sell, right? It's a reference design. Reference designs are very common in sort of the rest of the world, in other industries, especially surrounding electronics. And it's something that is very well documented and is open, and it's an example of what you can do. And it's meant so that you can take it and tweak it for your specific use case and build something new. Like, you don't have to start from, you don't have to reinvent the wheel just to like get your idea off the ground. Like I said, it's very, very common. Like, if you want to go and get some other electronic component, CPU, thing like that, they want to sell you chips, so they like provide examples of things you can do to help you get your idea off the ground. So that's a big part of what 256 Foundation projects are, is reference designs. So whatever your idea may be, whatever your theory as to what an improvement could be, is you can just hit the ground running, modify this, try it, see how well it works. I think that's really powerful. I mean, in the software world, we have the same kind of idea. All sorts of people make libraries, right? So you don't have to start from scratch. You can just grab a library and plug it in. It's well documented how to interface with it. And you just go.
components off the shelf. Thoughts?
Cuts. There you go. So it's going to be big.
And so that opening up that entire mining stack is what we think needs to happen in order for Bitcoin mining to become open sourced again. And we're not going to stop until that's done, even though we didn't hit a block yesterday. We're going to figure things out. But not only are these things going to work like you were saying, but some of these things are working. Like we did the telehash yesterday on the very early iteration of Hydra Pool, and the Ember One was hashing to it. So these projects have only been, the Ember One has been going on for 6 months, but Hydra Pool's only been launched for 1 month. And we're already starting to get some momentum here and get these ideas flowing and get some workable code out there. So the innovation won't stop till Bitcoin mining is free and open. And if you would like to support our mission, visit 256foundation.org and become a supporter. Thank you.